Okay, so question 4 is also detailed reasoning, and again, actually, we're thinking of that same kind of idea of making sure that doing something easy like solving quadratics, we're showing every step that we do. The functions are defined for all real values by f of x is x cubed and g of x is x squared plus 2. Write down expressions for these two things. Right, well, remember how this works. One part A, f of g of x is f of g of x. That means the input for f is going to be x squared plus 2, so that means x squared plus 2 cubed. And then we have it. We're going to make sure we show all of the steps for these things. Part B, g of f of x. So this is g of f of x. So the input to g is now x cubed. G was the input squared plus 2. So the input, oh, that's a 3. The input squared plus 2 gives us x to the 6 plus 2 as the answer to that one. There it is. There's our 1 mark for each of those. And then part 2. Hence find the values for which f of g of x minus g of f of x is 24. So that means the first one, that's 2. Take away the second one is 24. Did you notice I was careful to put the bracket around the x to the 6 plus 2? Because that bracket missing could lead you to add 2 instead of subtract it in what you do next. Right, we've got to sort this out, haven't we? X squared plus 2 cubed. Now actually they're thinking, in writing the paper here, they're thinking that's a binomial expansion, and students might do it as a binomial thing, and it's a test of whether you've done binomial. Actually, when I sat and did this paper, I didn't do that as a binomial. I did that as doing x squared plus 3 times x to the 4 plus 4x squared plus 4. So I squared it and then multiplied it by again. Take away x to the 6, take away 2 is 24. So that is x to the 6 plus 4x to the 4 plus another 3x to the 4. Is that right? I've turned that into a 3 somehow. What am I? That's the second time I've done something like that. Plus 4x to the 4 plus 2x to the 4. So plus 6x to the 4 plus 2x squared plus 8x squared. So plus 10x squared plus 4. And I think we ended up with that. Take away 2. I've also got a 2 there where I should have got a 4, haven't I? Almost makes me feel I should have started this video again. There. Take away x to the 6, take away 2 is 24. Have I done that right now? Are we happy with that? So that was x squared plus 2 squared gives me x to the 4 plus 4x squared plus 4. And then times it by the remaining x squared plus 2 gives me the x to the 6 plus 4x to the 4 plus another 2 of them is 6x to the 4 plus 4x squared plus another 8x squared is 10x squared. 2 times 4 gives me 8. Take away the other bits. Now I've got x to the 6 cancelling out to give me 6x to the 4. I've got you got 12x squared. Am I missed an x squared in there? Oh, it's 4 plus 8 is 10. 4 plus 8 isn't 10. Nobody pointed that out. 4 plus 8 is still 12. It hasn't changed. Okay. We've also got a plus 8, take away a 2, that's 6. Take away 24, that's take away 18. This has a common factor of 6. X to the 4 plus 2x squared minus 3 is 0. That is a stealth quadratic. At this point you could do a substitution of t equals x squared or something like that and then factorise it, or it's so easy to factorise, isn't it? You could just go straight into saying that's x squared plus 3 and x squared minus 1. Like that. which gives me x squared equals minus 3 and x squared equals 1. Now x squared equals minus 3 gives me no real roots, and because it's a detailed reasoning question, I have to clearly state that. So there are no real roots of that part of it. Okay, you have to state that, you have to show that you're not doing anything more with x squared equals minus 3. X squared equals 1 gives me the answers x equals plus or minus 1. So the answers are plus or minus 1. That's it, you had to finish that off. So, okay. Any questions?